All right, so I'm back to discuss the full point solution for uh, the third problem of the USACO December bronze contest. This was the tough one, uh, and my first solution was really just to try to get enough points to promote to the silver division. So in the last video, if you watched it, we're able to get 9 of the 13 test cases, good enough to promote, kind of a little bit easier. But there's one problem-solving insight that that you need to be able to get the full points, and that's really just that you don't need to compare the height to the height of absolutely every other number. You just need to compare it to one plant at a time. So compare it to the one smaller than it or the one bigger than it, depending on which way you go. Um, and so we're going to kind of talk through that here. I pulled up one of the input files. I think this was test case 8, that had some large numbers, but not so large that it's tough to see. Because I wanted to point out how this works. What we want to do is we want to go through and find the largest number in here should be this element, because this is the final result. It's going to say, okay, there's 0 that are going to be larger than it. So say this is I didn't count, but maybe the 18th index. Then what matters is that the 18th index number, somewhere around here, with whatever growth rate it has, ends up being larger than the item that has one element larger than it. So this one might be the 35th index. So we need to look up and find, okay, what's that starting height? What's that growth rate? And then you really just can compare them one at a time. So similar to before, really the insight is that there's only one. I guess they can't be the same height, so they just get taller as they go. So if you have that insight and you start comparing them one at a time rather than one to all the other numbers, it's actually code-wise pretty easy to solve, pretty easy to implement. The function that really helps with that in Python is enumerate. I love this function. It's useful when you need to keep track of an index as well as the elements that you're iterating over. So a lot of times we'll do something like for I and target in enumerate targets. I would be the index of, and then target would be the actual value. So that's kind of a shortcut, but really what it does is it gives you it kind of just puts the index in a tuple in front of the value. So then when we sort it, we can sort it by that second value, kind of that target number, and be able to have that index that we can access. So what does that look like? Comparing each item, and then figuring out for each one what is the minimal possible number of steps so that the height is greater. So I have that function here that again just does kind of that algebra to figure out how many steps is going to be necessary to do that. And then figuring out, okay, we want the maximum number. Once we compare all the numbers, all pairs of numbers to each other, figure out what the maximum amount is of that, and then see if it's valid. I just kept my same function as before, briefly looked at last time, but to go through it again, the official solution used some neat Python. But if you didn't know that, you can kind of just build it up on your own. Um, so it creates a map or a dictionary of the values, and it goes through it, and it goes through the sorted list, um, and keeps track of how many are larger than that. So if it's the first time it's encountering that, you know, it just would update it. So um, that's what we're looking at. And then if it's you know, not possible, then we print -1. But if it, you know, if it is, then we just print the value itself. I guess the number of steps that was necessary. Um, So that's the solution to get full points. Yeah, it's a little bit less code, a little bit more, you know, okay, really need to have that one insight to just compare two numbers at a time and realize that if uh, realize that, you know, the final list is just going to be increasing in order with no tied numbers, no numbers that are the same. Um, and that's what it looks like to get full points. So pretty good problem. Definitely tough. I didn't have that problem solving insight myself initially. But again, you don't necessarily need to have all of the insights to promote to the next division. You know, so make progress, get some working code, get some test cases on the hardest problem, and see how you do. All right, good luck next time.